In the previous unit, we learned about FlexB, the ROS tool we will use in this course to create robot behaviors. We learned to configure it, and we discussed the different views in its user interface. Now, we will get hands-on. In this module, you will learn how to use FlexB to develop your own robot behavior. Okay, we are going to create a simple pick behavior with the robot arm in our factory. The robot will move to pick a part from the conveyor belt and then retreat back to its home configuration. Note that for the motion of the robot, there is a joint configuration defined in the SRTF file of the factory, the R1 home, for the default standing state of robot 1. Okay, let's write down the basic state machine that we need for this behavior. We have that first, we need to detect the part and obtain its pose. The camera node provides this information in the factory. Next, we need to compute how to grasp the part. In the ROS system for our factory, we have a grasp planner node that, given the pose of the part, returns the robot joint configuration needed to pick it. Once we have this joint configuration, we need to move the robot to it for picking the part. For this action, remember that we can use the motion capabilities of the move group, as we discussed in week 4. Then, we need to activate the gripper. For this, we can use a ROS service provided by the gripper driver in our factory. And finally, we move the robot back to the home configuration. We can use the move group again for this action. Okay, now that we have defined the behavior we want, let's open FlexB and start implementing it. Here we are in the behavior dashboard view that we get every time we open the FlexB app. Everything we do in the FlexB user interface refers to the behavior that is loaded in this view. As you can see, when we start FlexB, there is a new empty behavior loaded for us. You can also load an existing behavior using the Load Behavior tool. But for the moment, we can directly start creating our new pick behavior. Okay. We start by filling the Overview section, which contains the basic information about the behavior. First, okay, here we are. First, we have to write a name to identify our behavior. Let's call it Pick Part from Conveyor. It is advisable to use something short but descriptive that clearly identifies your behavior. We can add more details in the description field. Here, we provide enough information so that when someone else opens the behavior, that person gets a precise idea of what it does. So here we can write, this is a behavior for the HRW ROS factory simulation that picks a part from the conveyor belt using Robot 1. Okay. We finished writing it. There it is. And we complete the description. Okay. Now, in the tags entry, we can add some keywords. For example, factory automation, robot arm, and pick. Next, we have to indicate the author of this behavior. Okay, that's me, Carlos Hernandez. And finally, the date has already been filled for us. So we are done. Okay, now we have written the basic information about the behavior we are creating. But we can see that there are more inputs in this dashboard view. The sections Private Configuration, State Machine User Data, and Behavior Parameters allow us to define different types of data and parameters that we can use in our behavior. We will explain them later when we need them. The private functions is a more advanced functionality that we will not explain in this course. Then, the state machine interface section is used to define the interface of this behavior. In this course, we will only be concerned with the outcomes for our behavior. This is where we can define the possible results of executing the behavior. By default, the defined outcomes are called finish and failed, which indicate that the behavior completed execution or failed at some point. We can rename these outcomes or add additional ones if our behavior has more possible results. Additionally, we can also use the input keys to define the data that we pass as an input to our behavior, and the output keys to collect any data that our behavior produces, so that we can use it after its execution. For the moment, we have defined all we need in this view. The next step is to create the state machine for our behavior. For this, we go to the State Machine Editor view.